Flow of control 1. If, then, else. So far, we've been exploring some basic programming. Right now, we're using Python kind of like a simple calculator. There's nothing wrong with that, but we could go further. Everything we've written so far does the same thing every time we run it. That is, we write lines of code, and when we run the program, those lines are executed one at a time in the order that they were written. But what if we want our program to be more flexible? This is where we can start looking at flow of control, i.e. the ways in which we can manage which lines of code are executed and when. If. Think back to data types and expressions. Remember that we covered something called a boolean, a value that can be either true or false, 1 or 0, yes or no. One of the primary uses of these booleans is in flow control statements. Say we have a block of code and some boolean expression, and we want that block of code to run if and only if that statement evaluates to true. Here's an example. Ignoring that 123 is a terrible password that you should never ever use in real life, let's clarify what it is we want to happen here and how we can make it work. We have some variable which we've called password. Here we've given it a definite value, but let's say we don't know what that value is for now. We want the rest of our code to behave differently depending on whether or not password has the value 123, i.e. if the boolean expression password equals 123 evaluates to true. If it does, we want to print out welcome, otherwise incorrect password. But we can't do this because so far our code runs line by line, meaning both print statements would be run. But there is a solution, and it comes in the form of if statements. You can think of if as asking the computer, when executing this code, run the following if this condition is true. The condition being some statement that will either result in true or false. In Python, they're very simple to write. There's really only three things to it. The if keyword, which starts the expression, the condition, that is the boolean, and the actual code inside the statement, the body. Once running a program, and it reaches an if statement, the body will be run only if the condition is true. Otherwise, it will be completely ignored and skipped over, moving on to the next thing. One thing worth explaining is the syntax of the body here, as we'll be seeing the same syntax very often from here on out. Notice two things, the colon at the end of the first line, and the space between the left-hand side of the border. This is the way Python structures blocks, that is, groups of lines of code. The colon indicates that we're ready to enter into a new block. The spacing to the left that comes afterwards we call indentation. This is done by the tab key on your keyboard, but should be added automatically by most editors. It's once this indentation stops that we'll have left whichever block of code we were in and gone back to the previous one. Remember, the body of the if statement is only the block that comes immediately afterwards. Any code after we've come out of that block is not part of the if statement and will be run no matter what. Else. So we can use if statements, and once we understand how code blocks work, we can use multiple if statements. Our example from earlier should start to look something a bit like this. Our first block will run if password is 123, and the second will run if password is not 123. And this works perfectly for what we wanted, but we can make it better. It seems kind of silly to explicitly define another condition just to be the inverse of our first one. That is, if the password is not 123, did we get the password wrong? We should already know that based on whether or not the previous if statement worked. This is the perfect time to talk about the else statement. The else statement is, put simply, the inverse of an if statement. Notice how it doesn't have a condition, just the else keyword and the body. This is because it doesn't need one. An else statement will run its body when the previous if statement's condition was false. If you like, you can think of every else statement as having an invisible condition, which is added automatically and is the opposite of the previous if statement's condition. And yes, this does mean that an else needs to immediately follow an if. We can't write an else on its own. We can't write one separate from an if. That wouldn't make sense. Not every if needs an else, but every else does need an if. Elif and chaining conditions. The thing about else-if pairs is that they're binary. That is, when the code is run, you can only have one thing or the other. Never both and never neither. In the context of the previous example that we were looking at, you either get the password right or you get the password wrong. But in many situations, there may be more than two options. We might want to check against 3 or 4 different possible conditions. This is where elif statements come in. Elif statements, which is short for else if, go between if and else statements. See that, like ifs, they do have a condition. They run when the previous statement did not, and when their condition is true. An elif must come after an if or another elif statement. They don't need to have an else statement at the end, but if you do want to include an else statement, it does have to go at the end. An if, followed by at least one elif, makes a chain. For each of the blocks, that is, for each of the bodies of the statements in that chain, only one can end up actually being run. Because if at any point in the chain a condition is met, then the corresponding body runs and the rest is just skipped over. If the chain ends in an else and no other condition before it has been met, not the first if, not any of the previous elifs, then that else statement is guaranteed to run. With the introduction of conditional statements, we've begun to see our first real emerging complexity. We're starting to see that even though at their core, programs really are just line-by-line instructions, this is by no means all we can do with them. We've also introduced blocks, a fundamental element of code we'll be seeing coming up again and again from now on. Next, we're going to look at some different flow control statements, their similarities and differences, and when we might need to use them.